guys, and welcome back. So today we will install the Z Axis, and we will configure the probe. The probe I have today to install here is the Pinda version 1. This is the original one from my old printer, and it works very well. This is not the one with temperature compensation. Okay, so this is the V1. So for today, we have the board exactly in the same spot we let last time. You can refer to my previous video to see how to install the stepper driver and configure the X-axis and Y-axis, okay, with sensorless homing. So we have placed the jumpers there for the X and Y and configure all the rest. If you won't need that information, go to the other video and see. If you have any doubts, please refer to the comments of the video so I can help you. But yeah, today we will use that probe. We need to change the connector. Let's remove this. We will connect the probe in the endstop Z Axis endstop connector here, and we are done. No, we are not. Let's attach the probe. Put up the board. I will let a link in the description for this small tool I have designed to remove the connectors. I have done this yesterday because sometimes people intend to pull by the cables, and that is incorrect because you can broke the connection between the cable and the connector. So use something like this to pull up the connectors. Is more secure. I will let the link on the video description if you like. So the board has boot up. Let's go to the computer now. So klipper is in the same spot we let last time. We only configure the X-axis, Y-axis. We set the sensorless homing. Okay, and that's it. Today we're gonna focus on the Z-axis, and for this we will need some information to set the probe as well. And to set the probe, you go to the klipper website. You can go to installations in configurations, configuration reference, and look for go a bit down, and you will find the bed probing hardware. And here you will find all the information to configure the probe. Okay, so the first thing we need to copy the TMC configuration. So for the Z axis, as I mentioned before, I'm copying the code here just for the video to show you on the video. Okay, it's more easy to so that you guys can understand how to configure this. You can set this the way you like. So we have the stepper Z, we have the TMC. Now we need to start copy the code. So let's copy the function of the probe. Add it to klipper. and let's start from here. So the pins are all correct, as I mentioned before. I have checked them; they are correct. Once more, if you have any doubts about the pins, you can go to the Bigtreetech manual that you have downloaded on the first video. That has the firmware folder. In there, you have the Bigtreetech manual, or you can address directly to the Bigtreetech GitHub and download the manual. But the pins are correct, okay? I have checked them. So step pin is okay, dir pin is okay, enable pin is okay, micro stepping is 16, rotation is 8 is okay for my this is a Cartesian. So endstop pins, we have to address this to the probe, okay? We'll go there in a minute. Position and stop is 0. We will not need this because this is the probe. Position max 270 for now is okay. You have to set this value depending on your printer. Position minimum, let's reduce this. This is the how much you want the nozzle go below the heated bed, so or the top surface. For me, -2, it's okay. Ohmic speed 8 is okay for the moment. Secondary ohmic speed is okay. And is okay. TMCs. So UART pin is okay. The voltage for the TMC is too high for me. Diag pin, you can comment or delete this line because we're gonna refer to the pin here on the probe. Okay, we're gonna see that just in a minute. Here. Okay. So first thing they ask us to set the probe is the pin. So copy the pin. You go to your code, pass it, and you can grab directly from the endstop pin up here in stepper Z. Okay. Next. They tell us that the activation on each sample. I don't want this for the moment. X offset. I don't need it, but I will place there. And I will explain in a sec. The Y the same. And the Z same. So this is the offset you will have from your probe to your nozzle tip. Okay, this depends from printer to printer. You have to set these values, but for this demonstration, I don't need it. I will let them there for the future, but for now, I don't need it. Speed, sure. This is the speed that the probe will work. Sample 1, it will do 1 sample. It's okay. You can change these values depending on what you need. Retraction distance. For me, 2 is too low for this setup. Let's try 3. Lift speed, I don't need it. Sample results average, sure, need this. But I don't use average, I use median. I prefer medium for this case. You can play with the sample result in between one and the other and see which one fits your needs better. Sample tolerance, sure. But let's go a bit crazy here. Yeah, sample tolerance. So sample tolerance retries. I will do 3. This is the number of tries in case it can read one time. It will try 3 times until it fails. Okay. more. Active G-code, I don't need it. Deactivate G-code, I don't need it. Okay, let's go back and see what I was telling you in the first place. The end stop pin, this one, where we need to map it directly to the probe. So it's already there, we already placed that, but we have to set a virtual pin here. For the probe is not the same as you use here, TMC20, it's not the same, but klipper tells you up here what you have to put there. Probe 2 points Z underscore virtual and stop. This is what you need. So you copy that and you place on stepper Z and stop pin, and is there. I know that this direction is incorrect, so I will remove the exclamation mark. In this case, with this exclamation mark, my setup will move the axis to the right. I want it to the left, probe to the left, so I remove it. And let's check everything. It's correct, it's correct, it's correct. 16 for the moment is okay. 8. So probe virtual and stop is okay. I don't need the position and stop because this is the probe. Position max is okay. -2 is okay for me. 8 millimeter second, it's okay. Second and homing are okay. For TMC, we have the pin, the voltage, and I miss here something that is my stealth chop. I want stealth chop. For the probe, we have the function, we have the pin, we have the offsets, we have the speed, sample retraction distance 3, median 0.06, 3 retries. Okay, let's hope that I didn't make any mistake. Let's see what klipper says. And all is good. Great. So now I will home the Z axis, and this is supposed to work. Let's check. I will pass to the camera now. So let's see what happens. There it is. One sample, correct. Everything is great. So this is working, okay? You can check as you can check the stepper motors at the end stop, stature by came here to the machine and stops and refresh. You can see that my Z axis is triggered. Okay, if I move it back, let's move. Let me pull to the PC. Sorry. So you go to the machine, and you go down here and stops. You do refresh, and you will see how the end stops, if they are triggered or not. In my case, I have pulled back the Z. So if I home the Z again, and we go there to machine and refresh it, the Z axis, the end stop, and the probe are triggered. Okay, this is correct. So now what we can do is to make a probing test to check the accuracy of the probe. And for that, I have built a macro that I have here. I've built this macro just to make a repeatability test. Okay, you can copy this from here, but I will place the code on the video description just in case you would like to try yourself this. This will do a G28 X. It will home the axis. G91 incrementing value, because we need to increment for this test. Usually is G90. Okay. G1 Z+3 is to back up the Z axis 3 millimeters, and then we run the function to probe the accuracy of the probe. As simple as this. Let's make a macro. Let's add a button for this macro. You go over here to the settings, then go to macros, add a group. Let's call what? Probe MP3D. The color, you can change the color. Yeah, let's go orange. Status. Show or hide if the printer is in standby. Standby, okay, it can show the button. If it is paused, no, because it's supposed to be printing. For some reason, we pause the printer, so I want to hide this button, this probe button, and printing, sure, hide as well. And I want to add this macro here that I built. So add, close, close, and let's see. Yeah, it's down there, but I want it here. So just stick with me one more second. So probe, go there. So now we have the repeatability testing here button. Okay, let's do a test. So I go to the camera again. I'll home the Z axis just for test. But the code I have on the repeatability test, the macro, already do the home, so you don't need to do. And the probe is running. So we are testing the probe. Great, that's complete. Let me now show you on the desktop. Oops, sorry. Okay. So in the desktop, if you go to the console, you can see the test we have made here. Okay. It has made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 probes. Okay. 10 tries. And for every single try, the deviation was exactly 0.007500. So in all 10 points every day exact same value. This is great. This is a great probe, of course, but and we have to take in account that this setup is bulletproof. Okay, so you don't have all the things you have in your printer, the cooling fans making resonance in the structure. You don't have anything of that. This is a bulletproof setup, so nothing will interfere with the probe. That's why I built this, to test the probes and see if they are really good. If they are, all the rest are problems that we have in our printer. Some motor that may have some issues, some misconfigurations, something like that. But for this, we are testing the probe in a good environment. So if I run again the probe, you will see I clear the log. And I will run and show you the console. Okay, S run. As you can see, the deviations, the standard deviation is 0. This was in a perfect world. Okay, of course, that if I pull multiple times the probe, I will probably get a small error here, because every single printer has small errors. Okay, that is normal. But yeah, this probe is great, and this setup is also great for this, and you can have an idea on how good is your probe if you run this accuracy test. Okay. So guys, I think I have once more covered more or less everything I know about the Z axis configuration and probing. Okay, I have probed with this with the inductive sensor, but if you'd like, I can show you how to set up the BL Touch also. I think I have one there somewhere. I have on the other printers the BL Touch working, um, but I can get one, a knockoff one, just to show you if we need. Um, but yeah, guys, this is how I configure my Z-axis and the inductive sensor probe. I hope you all enjoy this video, and if you need any help, of course, please contact me on the video comments. I will try to help you as soon as I can. Okay. Thank you. Bye bye.